Okay, hello everyone. In a new video. In this one we are going to solve an exercise related to optics in the chapters of lenses and formation of images. This exercise was a previous one in the brevet exams in 2019, first session, exercise number 2. The title of this exercise is Converging Lens. Consider a converging lens L of focal length f. F is the object focus of L and f prime is image focus. A luminous object AB is placed in front of the lens, document 2. So they mentioned the document, so now I can use the document. In number 1, they are telling me reproduce document 2 with the same scale. Okay, so whenever we need to reproduce the document, we always start by drawing the optical axis at the center. This is the optical axis. Notice that here they didn't indicate the direction of propagation of light, but from this arrow we can know that the direction of propagation of light is from left to right, having the same direction of the optical axis, okay, positive x-axis. So this is x prime x. Then we place the lens L perpendicular to the optical axis at the center using the correct symbol. And now the intersection between the optical axis and the lens L is the optical center O. Okay. The point F is located 1, 2 divisions in front of the lens. And F prime is the symmetric of F with respect to O. Moreover, the point A is located 1, 2, 3 divisions in front of the lens. And the point B is located 1 division above A, in which a hat is found on B. Now let's trace the object. And the point I is located 1, 2 divisions upward on the lens. And BI represent a luminous incident ray issued from B. And we don't forget arrows on light rays that indicate the direction of propagation of light. And the scale is given by 5 centimeters along the x-axis and 2 centimeters along the y-axis. Okay, hope we didn't forget anything. Now in number 2, they are telling me determine f, so we need to determine the focal length. Okay, we have the position of the image focus, so we can calculate the focal length using its definition, which is given by the focal length is the distance from the optical center to the image focus. So whenever we need to calculate the focal length, we always start by writing the definition. And now let's calculate the focal length. So the focal length is the distance from the optical center, which is the point O, to the image focus, which is the point F prime, and we don't forget the bar because this distance may be positive or negative. And now the focal length is given by the distance from the optical center to the image focus F prime. Okay, so it is the distance from the optical center to the image focus, which is in the same direction of the positive x-axis, so this distance is positive. And now we count the number of divisions between the optical center and the image focus. We have 1, 2. And we multiply by the scale along which we have counted the number of divisions, which is scale along the x-axis. And this will give me 10. Because the scale is in centimeter, then the value of f will be in centimeter. And always all quantities in physics must have a unit. So the focal length is equal to 10 centimeters, which is a positive number, and which verifies that the used lens L is a converging lens, because we know that for a converging lens, the focal length is positive. Finally, it's a good habit to write our final answer in a box to make the task easier for the corrector to notice our correct answer. Okay, So this is it for part 2. Now in number 3, they are telling me A1, B1 is the image of AB given by L. Let me make some space. Okay, 3.1, construct A1, B1. Okay, so we need to construct the image A1, B1 given by L. Okay, and the word construct means that we need to trace and justify at the same time. Notice that till this moment we didn't trace any rays issued from B. Okay, so here by construct we need to do all the steps. So we need to trace the rays and justify their path, as well trace the image and justify its tracing. Okay, so in order to trace the image A1, B1, we need to consider two incident rays issued from B in which we know how to complete their path. So the first one is parallel to the optical axis. This ray will emerge passing through the image focus. Okay, and the second ray that we need to consider is passing through the optical center. It will emerge without deviation. Okay, and we don't forget arrows on light rays, incident rays, as well as emergent rays. That indicate the direction of propagation of light. Okay, so now what we have done is a tracing of the rays. Now let's justify their path. Okay, for the first ray, which is parallel to the optical axis, let's say that an incident ray issued from B parallel to the optical axis emerges passing through the image focus. Now let's justify the second ray. An incident ray issued from B passing through the optical center. Emerges without deviation. So now what we have done so far is the tracing and the justification of the rays. Now we need to trace and justify the image. Okay, we know that always the intersection of the emergent rays is the image of the object. Notice that these emergent rays are coming from these incident rays that are coming from the point B. Therefore, their intersection point, which is this point, will be the image of the object B. The image is denoted by B1. Moreover, a hat is found on B directed away from the optical axis, like this. Therefore, we must place a hat on B1 directed away from the optical axis, like this. This is the hat. Moreover, here the point A represents the foot perpendicular of B on the optical axis. Therefore, its image A1 will represent the foot perpendicular of B1 on the optical axis. This is the point A1. And now let's trace the image. And now let's do the justification. Okay, so what does B1 represent? Then the image B1 of B is the intersection of the emergent rays. Now notice that here the image A1 B1 consists of 2 points, consists of B1 and A1. So we have justified the tracing of B1. Now we need to justify the tracing of A1. So what does A1 represent? And A1 is the foot perpendicular of which point of B1 on the optical axis. Okay, so this is it for 3.1. In 3.2 they are telling me give the nature and the direction of A1 B1. Let me make some space. Okay, so now we are in part 3.2 and we need to give the nature. Okay, whenever we need to give the nature, it's better to justify. Notice that here the object AB is in front of the lens and the image A1 B1 is behind the lens. Therefore the object and the image are opposite sides of the lens, and whenever the object and the image are on opposite sides, this means that the image is real. So let's say that since the object AB and the image A1 B1 are on opposite sides, then the image A1 B1 is real. Okay, and now we need to give the direction of A1 B1. So by the direction it means that we need to say whether it's inverted or erect. Then let's write here direction okay. Notice that here the object AB is pointing upward, whereas the image A1 B1 is pointing downward, which means that the image A1 B1 is in an opposite direction with respect to AB, which means it is inverted. Then let's say the image A1 B1 is inverted. With respect to the object AB. Now in number 3.3 they are telling me determine graphically the size of A1 B1, which is the image. So now let's calculate its size of the image. Now A1 B1 consists of 2 divisions, and we multiply by the scale along which you have counted the number of divisions, which is scale along the y-axis. So this will give me 4. Because the scale is in centimeter, then the value of A1 B1 will be in centimeter. Then the size of the image A1 B1 is given by 4 centimeter. Okay, now in 3.4 they are telling me complete with the justification the path of the luminous ray BI. So complete with the justification the path of the luminous ray BI. So we need to trace the path of this ray and justify it. Okay, notice that this ray is not a particular ray in a sense. It's not parallel to the optical axis, it's not passing through the optical center, and it's not passing through the object focus. So we don't know how to complete its path. However, because now we know the image B1 of B, we can complete the path of this ray because we know that all the rays issued from B, all incident rays issued from B emerges from the lens going to B prime. So let's trace this ray first. Then this ray will go to B1. And we don't forget arrows on light rays. Now let's do the justification. All incident rays issued from B emerges going to B1. Okay. Now in part 4 they are telling me does L in this case act as a magnifier? Justify. So they are asking me if the role of the lens here is a magnifier. Okay, the role of the lens can be determined from the properties of the image. Okay, so if the image is virtual and larger in size, then the role of the lens is a magnifier. But notice that here in 3.2, when they ask me give the nature, we have justified that the nature is real and not virtual. Okay, for this reason, because the image A1 B1 is real and not virtual, therefore in this case L it doesn't act as a magnifier. So the justification is given by, or the answer, since the image A1 B1 is not virtual because it is real, then L doesn't act as a magnifier. And by this we have finished solving this exercise. Hope it was beneficial for you guys out there watching this video, and see you soon in another one.